Today we are going to talk about the multiplication rule of probability. So multiplication rule of probability basically states that the basic idea of multiplication rule is that for finding a probability for P of A and B, so that means the probability that event A occurs in the first trial and event B occurs in a second trial. What it means is that the first event somehow affects the probability of the second event B. Okay? Kata, evento da primeiro A nene, ni acontece tiona no ni acontecimento ni orsida afetamos o bahira o halo kalkulasan ba evento B ne. Também na makita tenki tamo to neve bahira o halo kalkulasan ba ya probabilidade ba evento B. Então, almost tem que halo ajustamento. Não sei. Now, so that's basically what multiplication of probability means. So the notation of multiplication of probability is like this. So pretty much you written as P of A and B. Okay, P of A and B. Yeah, A, yeah, addition ni. So in addition, you use the word or for addition. Does it lie? Agora may multiplication ito usa sa and. The word and for multiplication. Okay. So basically, when I write P of A and B, that means probability of event A occurs in the first trial and event B occurs in the second trial. So if I write P of B given A, represent that the probability, this one represents the probability okay, so this one represents the probability that event B occurring after event B has already occurred. So this straight line here is given, yeah. That means that probability of event B given that event A has already occurred. Okay, after event A has already occurred. So the formula for multiplication of probability is like this. So basically, the formula for probability multiplication is P of A and B is basically, so you're calculating first, you multiply probability of A, and then you multiply by probability of B, but given that A has already occurred. Okay? It's simply just multiplication of probability A to probability of B, but you also add another condition. The condition is, what is the condition? Event A has already occurred. Has occurred when we calculate probability of B. Therefore, instead of representing just P of B, we are representing probability of B given that A has already occurred. Understand? Comprende to?
No, teacher.
Any questions?
None, teacher.
Okay, so just like addition rule where you have join and disjoin join and disjoin event, in multiplication probability, we also have what you call an independent events and dependent events. Okay, Ildefanus, can you please read the independent for us? Ildefanus, Pinto. Okay. Celsius, can you read the independent events for us?
Okay, teacher. Independent, two events are independent if the occurrence of one does not affect the probability of the occurrence of the other. Several events are similarly independent if the occurrence of any does not affect the probability of the occurrence of the others. If A
Can you
and B
speak
are
far from
independent.
microphone, please? Your voice is kind of all over the place. A little bit farther from the
Oh,
microphone.
I'm sorry. My voice are my throat a little bit sore.
Okay. All right, I thought it was all right. Thank you.
If A and B are not independent, they are said to be dependent.
Okay, so this says here that two events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. Remember back to the formula, saccadic the occurrence of A, occurrence of B does not affect the if the action of finding the probability of A does not affect the action of finding the probability of B, and event A and B are said to be an independent events. Okay, if they are not independent, then your formula is just simply P of A dot P of B only. Okay, just like independent, you also have the dependent event. So two events are dependent if the occurrence of one of the M affects the probability of the occurrence of the other. But this does not necessarily mean that one of the event is cause of the other, yeah? Does not mean that one event is causing the other. It's just simply mean the action of calculating the probability of event B is affected by the event A that's already occurring. I keep on repeating this. So for the dependent and independent probability, you represent it by different formulas. So for the dependent multiplication rule of probability, you are going to use this. You're going to use this representation. So if you notice between the two, the only difference between these two formulas is this section over here. This one and this one. Okay, so this one is a dependent. That simply means when you calculated the probability of B, the event A has an effect on probability of B, meaning event B is dependent on event A, but this one is event A and event B are entirely independent. Okay. Now, let's do an example. What is the probability of getting a hat? Okay, so this is it has to be the other way around, yeah. Wait a second. Okay, so what it means is that, so what is the probability of getting a hat in two consecutive coin toss? So that means is that sekarang imisoy osam besine dalarua tutirmalu, yeah? So event A, nemasayda? Getting a hat. So let's say event A is getting a hat. Get H in the first tossing. That's one event. Event B is also getting a hat in the second tossing. Now, my first question is, does event A and B is an dependent event or independent event?
Dependent event.
Why?
No, wait, I think it's independent event.
Why? The correct answer is independent event, but do you know the explanation as to why? So basically, what it says is that, so when you the pertama kali misoy coin ne, the first time when you throw this coin, right? When the first time you throw this coin, okay, the first time you throw this coin, even if you get head or tail, right? And then the first time you get let's say the first time you throw it, you're getting a head, for example. And then you throw the second time. So when the second time you throw, does the first one has an effect on the second one? Yes or no? No, it doesn't, because the coin are just the same. You repeat the experiment, but the event A that occurs does not affect the event of the second event. So we can say that. So, nega, comprende kalian? Kata, comprende to?
Yes, teacher.
Understand? Yeah. So basically, pertama kali ba this is ida independent event, yeah. So pertama kali, por exemplo, ademia maksoi osang ne. Pertama kali ademia soy osang ne, ini probabilidade saida. Probability of getting ahead of tossing a coin. What is the probability? It's simple. Huh? What is the probability of getting ahead in the first when tossing a coin?
50%.
Yeah, it's just one out of two probability, huh? It's simply just 1 out of 2. Now that's first tossing. Bahira ademia swipe pertama, first tossing. Now, hotutia ademia 14 afating coin the same coin and then do the same and repeat the same experiment. Now it will also get you the same thing. It's still 1/2 probability of the second tossing. Now the act of tossing the second one does the asang ida be 40 hanene afeta ba asa sorry. Does the event occurs in this has an effect on the event occur in this? No, because they are independent. So because they are both an independent event, so you simply calculate probability of A and B is simply what? Probability of A dot probability of B. Since of both of them are just simply 1/2, you will have 1/4 or approximately 0.25. Comprende to?
Comprende,
Yes,
teacher.
teacher.
All right. So what about the next one? What about this example? So for example, suppose you take a 50 drug test results are given from people who use drugs, yeah. Por exemplo, a companhia medicina ida, sida foi desenvolve a morufong ida, por exemplo, yeah. Okay. Now, por exemplo, last an exemplo dia. Por exemplo, imi hakarak 40 ema 50 atu teste katak emane drogado gala drogado. Contohnya. Okay. E depois, ema 50 ni olor ba 40 ba teste, o hetang katak 44 of them is a positive test result of the drug. Okay, so 44 of them are positive test result. Please close your microphone if you're not using the microphone. Okay, so 44 of them are positive test results and 6 of them are negative test results. So the total is 50, as you can see. Now, it says here, if 2 of the 50 subjects are randomly selected without replacement. Without replacement, maksudnya ano you want to select 2 subjects, yeah? You want to select 2 subjects. So subject 1 and subject 2. Person 1 or person 2, for example, yeah? Without replacement, katak banhira o 40 sujeito ida, 40 or ema pertama, ema ne o latau filafalio na ba nini gru latau filafalio na. Banhira o 40 ema ida loriba teste tia, one total ema nene 50 laos 50 na ni sai falihira. 49 de tona, tamo o teste tena ida o 40 tena ida lo sale. Nema diang without replacement. Sekarang without replacement. Kuleba, hemat kuliah na. Without replacement means that bahira o 40 teste emane o latau fila faliban ini sample size neona. If o 40 size teste manena, that's it. Okay, so you want, if two of the subjects are randomly selected without replacement, now find out that the first person tested positive and the second person tested negative. So you want to know, find the probability that the first person tested positive. So A, first person, positive. And then B, event B, the second person tested negative. Okay? So how do you calculate the probability for this? So my first question becomes, is this a dependent event or independent event? Are these two events dependent or independent event? Okay, before that. Now, what is the probability of A? Huh? What is the probability of A? If you randomly select and you want to know what is the probability of that person is a positive drug test, what is the probability?
44 over
44.
Out of 50, right? Because you have 44
Yeah.
out of 50 positive test results. What about probability of B?
6 over 50.
6 over 50.
No, not 6 over 50, 6 over 49. Why 49? Because there is a word here that without replacement. When you select, when you calculate the probability of this, you already select one person, right? And when after your selection, you do not put this person back into the sample of selecting. Comprende?
Yes, teacher.
Yes, teacher.
Okay. Already select one person. One person without replacement. So that means the action of finding the probability of A has an effect of finding the probability of B. Logical. So that means that probability of B is dependent on probability of A. So therefore, this is a dependent event. So to calculate the probability of A and B, so you use the formula for dependent events. So probability of A dot probability of B given that A has already been selected. Okay, so that this is technically given that A, yeah. So basically you have 44 over 50 dot 6 over 49. So what is this? What is this value? This is 50, yeah. So it's very, very low probability. So you get about 0.11 probability. Okay, so 0.11. Comprende? Any questions?
Sure.
Yes.
Yes.
Ya, perguntas itu ya berladung comprende probabilidad ini. Ini bahkan ini positif test ini resultatnya kan ida ya ini 40 44 ini memang ya tahu ini resultado. Maybe my falle be probabilidad B per A ini bahkan enam per 49 ini bahkan ya probabilidad ini already select one person. Ini bahkan 44 orang mah ita foto ini sampai niatan resultado. Tapi teman saya mah sampai kurang satu deh, tanda 50 tumba unde.
Tambah oka tu hili ema naing rua date. You only select, they say if you select 2 of the 50 subject. O hili tia ema ida. Depois o hili ta ema rua. Lo salah? Ema rua ne waktu hili tutir malu. Bahira o hili tia ema primeiro ida. Ema ida o hili tia ne ola tau fila fali ba iha ni total ema ne. Agala. Meskipun ida ema probabilidade ida sukat ne kan tamania ema 44, totalnya 44, kusi 50 orang nebe halo tes teba ne. Mabe bahira o calcula probabilidade ida nene. O ema ida por exemplo o hili site nene o katu hili ema nai rua to 40 site na ema ida. O 40 site ema ida anto ema nebe 50 ne halo to na 49. Atau bahira ida nene asam da hili ema kedua naman selecting first person. This is selecting the second person. Second person. Okay. Bahira o selecting the first person nene. Total ema 50 ni laos 50 na. Agora ni saya fala 49 também não é 6 né per fala 49 not 50. Is that your question? Ni perguntas me nene será?
Iya, maknanya.
Okay. Did I answer your question? Comprende, na? Comprende, na? Sedap.
Yes, teacher.
Okay, what about this one? Draw through 2 cards from a deck of 52 cards. O, por exemplo, o atu dada kartu rua ni saída olah tene. Atu dada kartu rua, husi kartu 52 ne. Mai be, ni husu. Agora, hausu dali detan fila fali. Probabilidade ne saída, probabilidade ne o atu halo predição, ka mathematical prediction of guessing something, the likelihood of something to occur. Waktu seek ida, waktu seek buat ida, no atau hatene kata buatnya si acontece gitu. Tamerane, por exemplo, otaka tiona mata o karak haudada dalam rua titir malu nene, probabilidade saída maka harus hetang asrua. Gitu. Tiri mini hanoi ne probabilidade buat ga kick. Just imagine. I think it's very small because you only have 4 aces and you have a total of 52 cards. So it will be a bit difficult, right? So, but letter A is with replacement. Agora kita halo look with replacement look, yeah? With replacement. Okay? Okay, hold on. Let me just make some symbols. So let's say A is the drawing of the first card. Draw first card. Card number 1. B, draw card number 2. Okay? O hakara katak evento A o B nene, o hakara ketang tu aso tu keras. Então, may probabilidade ba ida nese acontece ne masaida. Okay? If in a condition with replacement, okay, draw card 1 as an ace, yeah, as ace. Both of them you want to get an ace. Okay, so probability of getting A, drawing an ace is what? 4 over 52. Agora, mai fali bahira waktu dada kartu de segundo, o setelah o dada te kartu primeiro nene, o tau fila fali ba iha kartu nya tomak ne. Jadi 52 ne tetap 52. That's what we mean by with replacement. This is what we mean by with replacement. Meaning after you draw it, you put it back to the deck of cards. So this becomes still 4 over 52. Therefore, probability of A and B. These are all, this is an independent, right? This is an independent event. So P of A dot P of B simply. So it's just simply 4/52 dot 4/52. Okay, the probability of that is very, very low. Imagine this is like a 0.006%. That's approximately 0.06%. That's a very, very low probability. Which makes sense, logically. Masuk akal to. Si otakat yun, otaba tamay makartu ne mako. O hakarak dada kartu do titir malo ne ruane hakarak aso to. Probabilidade de nesse acontece is very, 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 very low. Like it's not likely to occur, yeah? It's not zero, but close to zero. Comprende, to?
Yes, sir.
Okay, what about the second one, with replacement? Without replacement, sorry. So without replacement, so you will have probability of A, it's 4/52, right? But the probability of B now becomes what? 4/51.
50.
4/51, logically. So this is a dependent event. So you have probability of A and B is equals to probability of A dot probability of B, given that A has already been selected. So you have, so let me just rewrite this. So P of B given A has already been selected. So you have 4/52 times 4/51. So what you got here? So 0.006 is still almost the same. Yeah, approximately 0.6%, yeah, which is very, very low. Oh, this is 0.6, not 0.06. I'm wrong. Okay, so approximately 0.6%. Bahira imi ato be. Halo be, sada? Betting rumah. This is a good chance to win. Sekarang imi ato halo taruh main karik dia itu taruh tok. Kalau taka matang anak sana itu taruh $1. Kartu ro dara titir malu ne sela hetang A. Ne probabilidade be o manang ne makaslos. There's no way, there's no possible way that a person will draw two aces. The person might draw one ace, but two of them, that's just like close to impossible. Okay, so when that is how you use probability to guess or represent the guessing into a mathematical expression of some sort. Okay, what about this? No, I don't like this example. Next example. Okay. So any questions about the multiplication, basic concept of multiplication of probability?
Teacher, if you can go back to the deck of cards thing, I have a question I need to ask.
Hold on, let me just go back to. Okay.
I'm wondering about the A? How did we get 4?
How did we get 4? Which
Yeah.
one? Is that the
The
with replacement or without replacement or both?
with the both the
4 because you have 4 aces.
okay.
So ace of clubs, ace of spade, ace of heart, and ace of diamonds.
Okay. Okay, thank you.
Okay, esta pregunta, Cielo.
None, teacher.
Okay. All right, so tree diagram. I think imi be hetan tena tree diagram before, but hindi tahalo example ba iha be probability of 2 boys in a 3 3 children household ne. So tree diagram is basically just a picture of possible outcomes. A tree diagram is just a way for us to find the sample space of certain experiments. Okay, so tree diagram is a picture of the possible outcome of a procedure shown as a line segment emanating from one starting point. Now, these diagrams are sometimes helpful in determining the number of all possible outcomes in a sample space if the number of possibilities is not too large. Okay, so for example, ano sa na yan? Okay, for example, this figure summarizes the possible outcome for a true-false question followed by a multiple choice question. Note that there are 10 possible combinations. Then for example, this summarizes the true-false question. Imi perguntas rua. Perguntas primero ne maka imi heta ninya perguntas primero ne anya option ne either true or false. My best option segundo ne a multiple choice question A, B, C, D, and E. Okay, so there are 10 possible combinations. Ema ida bella ruma ema ida bele hili question primero ne as a true. May ba second segundo ne hela tia ne mo ne fali. Oh, ema ida fali man bele heta ne question primero ne heta hili tia a. Ne question segundo ne hili b and etc. Oh, ema ida ne question primero ne hili f. Ne question kedua ne hili a. May ba imi nota ya question primero ne ni option ya hira iherua. Question segundo man ni option iha 5. Nebe o to calculo all the possible outcome nene o la precisa ta o atene ona kata o kali option primero ni option rua. Question primero ni option rua. Question segundo ni option 5. Maybe o nebe o kali hamutuk 2 times 5 you get a 10. So this 10 represents all the possible outcome, all the possible sample space. Like this. Okay, nebe or sila bahiri mi comprende ona ida neken. E mi comprende na oh, então ação primeiro nem é opção rua. Ação segundo nem é opção 5. Ah, então ato buka ne total sample space, hanya all the total possible outcome ne. Então tinha candidate 2 multiplied by 5, I get a 10 possible outcome because this number 10 is all I care about because this number is what I'm needed to calculate my probability. So that's what tree diagram is. Comprende, galera?
Yes, teacher.
For example, just another example, yeah. For example, I have some example later I can show you to use. For example, like this. A couple wants to have 3 children. What is the probability that we'll only have boys? Nate halta nang ihabe. Koto ka sama sada ya segunda nelos kala. But for the sake of experiment to show you the tree diagram, let's do it again. So you want to know what's the probability of 3 children, right? So children number 1 is either boy or a girl, and the second child is also either be a boy or a girl. Okay, and the third children is also either be a boy or a girl, boy or a girl, boy or a girl. Okay, so how many? So one event. So this will becomes boy, 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 girl, also like, and then boy, girl, boy, and then boy, girl, girl, and then you have girl, boy, boy, and then you have girl, boy, girl, and then you have a girl, girl, boy, and then you have all 3 girls. Okay, and then when you sample space, so you have 8 of sample space of 8. How do you get an 8 over here, huh? So basically, every option you have 2 outcomes, like 2 possible choices. So you have 2 possible choices for every child. So 2. How many child do you have? 3. So that will be simply 2 times 2 times 2. It just gets you 8 possible outcomes. So when you look at here, this is also 8. 8. So this is all 8 possible outcome, right? So 1 possibility, 2, 3, 4, 5, 6, 7, and 8. Okay, so tree diagram helps you to determine the total number of possible outcomes. Okay, so if we really wanted to calculate the probability of only have boys, so let's suppose B is only boys, only have 2 boys, only have boys, yeah, not 2 boys, only have boys. Only have boys. Okay, how many events that only has boys? Only one event that only has boys, Lozale. These all the things that have boys. So probability of B is simply 1/8, or approximately what? 0.125, or approximately 12.5%. Okay? Now, comprende ka la? Esempio ni mi comprende ka la?
Yes, sir.
Okay, what about these questions? Efradia, please read number 7 for us.
You're taking your family to the restaurant. The restaurant menu is divided into sections: pork dish, fish dish, and vegetable dish. There are 3 different pork dish, 2 different beef dish, 2 different fish dish, and 3 different vegetable dish. Develop a tree diagram for selecting each types of the dishes.
Okay, ini dia nessane. Per esempio, imi lori mine famiglia to bahang ya restaurante ida. Right? No, iha restaurante nene sirnya menu ne fate ba section ida be nang fahin ini ya. Or what we call pork dish. So pork dish have how many options? You have 3 different options, 3 options of pork dish. And then you have beef dish, you have 2 options of beef dish. For example, pork ne pele iha midersing, sona marang, kung sa datang latin ne tini be reseta sam. For example, beef ne ida fali ne be barbecue, ida fali ne calderada, for example. Iha opsang makruaret. At nang karaw ne iha opsang rua, nang fahi ne iha opsang tolo, ida depois fish is how many options? You have about 2 options of fish only. For example, one is fried, one is grilled. And then you have also 3 different vegetable dish, vegetable. For example, iha kangko ay fernetahan ho moramuti, for example. So 3 options. Agora, o karak atu hili, each dish ida from ini karak atu hili one dish from each. And how many possible combination of all these 4 dishes are possible? Lazalai. So ita halawan sa nede ita bazeba o intatene ninya possible combination has to be 3 times 2 times 2 times 3, which makes it about 3 times 2 is 6, 6 times 2 is 12, 12 times 3 that will be a total of 36 possible combination, yeah? 36, imagine that. So how do you develop a tree diagram on that? So the first one is you have a beef. Okay. So beef, so let's call this beef 1, beef 2, and then beef 3. Now, after you select a beef option, now you are, which is only 3, wait. This is beef is only 2 options. I'm right. Let's start with pork. So first you want to select with the pork option. So pork has 2 options. You have pork 1 and then pork 2. That is the menu. I'm just calling this that. And then after you select a beef dish, a pork dish, you are going to select beef dish. Beef dish can be beef 1, beef 2, or beef 3. The same thing here. Beef 1, beef 2, beef 3. Now, after selecting beef one, now you have two options of fish. Fish one, fish two. Fish one, fish two. Fish one, fish two. This is also fish one, fish two, fish one, and then fish two, fish one, and then fish two. Now, after you select, now you select vegetable dish. So 1, 2, 3. So V1, V2, and V3. This is also V1, V2, and V3. This is also V1. So it's the same thing, yeah? So basically, the combination of this, either you get the first combination of pork 1, oh, sorry. Okay, so the first combination, either the first one you select pork 1, beef 1, a fish 1, and vegetable 1, or you can select pork 1, beef 1, fish 1. This is all possible choices. And vegetable 2. Or you can go pork 2, beef 1, fish 1, vegetable 1. This is also possible, but whatever they choose, all the possible outcome of this has to total 36. La bahiri mi haray na kan how haltan 3 diagram barak los terlalu. Nuke how kanta how calculate ida baretonam. Agora, to answer this question is develop a 3 diagram for selecting its types. This is your 3 diagram. How many espacio malato na be imi comprende de tone or sila imi comprende to nene. Imi comprende kala? Imi bele imi haker ke imi livro ka suratan ka imi bele haker ke imi suratan halo bubol. Okay, that's what 3 diagrams is, okay? Any questions about 3 diagrams? Perguntas rumah? All right. So, probability of finding at least 1. Okay. So, to find the probability of at least 1 of something, so you need to calculate the probability of none of something, then subtract that result from 1, that is probability of at least 1 is equal to probability of none. Okay, deve idane ato similar ato hanesang ho condition asada complementary probability kalan. Pelo menos ida, bahira at least 1 tetungkar jam pelo menos ida. Pelo menos ida nini terbalik usi pelo menos ida ne saida. Layaliu lo salah.
Layaliu.
Yes, at least 1. Neve bahira o hatene una probabilidade ida o pelo menos hetang ida nene. O tinggal subtract that 1 who's the probabilidade nebe o sila hetan liu. Then you can get probability of at least 1. So just remember this formula. Probability of at least 1 is simply equals to 1 minus probability of getting nothing, none. Okay? Now, what is the Buffalo conditional probability? Okay, Favan, you read this for us. Oh, Favan, are you here? Alessandra, read this for us, Alessandra.
Okay. Conditional probability of an event is a probability obtained with the additional information that some other event has already occurred. Denotes conditional probability of event B occurring given that event A has already occurred.
Mhm.
and it can be found by dividing the probability of event A and B both occurring by the probability of event A.
Okay, then yang conditional probability. Maybe bahira imi hare di diak formula ida ne. Bahira imi hare for di diak formula ida ne. Formula ida ne mayusi formula ida ohin de hare ne. Probability of A and B is simply equals to probability of A times probability of B given A. Lo right? Maybe imi rearranging de tirane imi etam probability of B given A is equals to probability of A and B over probability of A. Okay, the conditional may the name of conditional kata buka probability B event to ane a contestation. That's what entails conditional probability. So okay, so that's what does that mean? The conditional probability of B given A can be found by assuming event A has already occurred. Okay, let's just do an example. No. Okay, so refer to the table. Find the probability that the subject actually uses drugs, given that he or she had a positive test result. Okay. Agora, idanene imi hakarak atu poti teste ba iha ema ser nebe usa droga. Los galang. Agora, sebanhira ema nema kat nia teste duni positif, nia subject ni usa duni droga. E depois nia bahalo teste, nia mos nia teste ne confirmado duni katak nia ne droga iha. Ida ne metabol naran true positive. True positive. Katak nia usa droga, true katak nia usa droga, positif katak nia positivo duni nia heta, bahira nia halo teste ne nia positivo. Agora, ida ne fali false positive lá ia. E mane la usa droga, mas be bahira ba teste ne ni heta fali positivo teste droga ne. Então itu ida ni tabel yang kata oh da rumah buat teste ida ne be itu usa ne ma da rumah ladun dia kira kari. Agora mai fali ida ne fali e mane ne usa droga, mas be bahala teste ni heta fali negativo. Agora ida ne fali wait, ida ne false negative. Subject uses drugs. Emanene usa droga. Mas be teste mainene negativo fali. Artinene falso. Nia usa ela droga. Mas be teste ne fofal negativo. Anto resultado ne be nia fonene la losida. Agora mais fali ne emane la usa droga no resultado ne negativo duni. Então ida ne metebol na true negative. Tamania la usa droga. Okay. Now, given that he or she positive test result, okay, find the probability that the subject actually uses drug. Okay, so let's say probability of A is using drugs, given that he or she and P is positive test result. Okay, you want to know what is the probability, but here I can find the probability that the subject actually uses drug. Using drug. Wait, sorry. You want to calculate that the probability that the subject is actually using drugs, given that this subject is a positive test result. Então, imi hareya ne, ato hakere kene formula kare kung sa probability of A and B over probability of B. Oh, sorry, ini lost B deh. P tiap tafel B. How is the PP dobrar te fare troca? Let's change this to B. Ne per la vera confusione. Let's change this to PO, positive. Okay? So, and then over PO, so probability of A and B, meaning using drugs and tested positive, this is true positive, which is 44. Nema yan numerator na ba? Over probability of the positive test result. So that will be 44 plus 90. 134. Betul? Yan eh, hamni kalkulusan iyalah, manehla. Okay, so probabilidade ne mane. So dine kalkulasan ne mane. Subject uses drug and subject to positive test result. Ni usa droga no subject to positive test result. Ne maka idanene. Ne maka siya sound idanene. Atau kalkula probabilidade ne ni totalnya kan 44 tambah 6 tambah 860 tambah 90 ne. Totalnya be. Saya 1000 ya. Tambah ne 44 bagi 1000 ne maka heleteng na ba? Ne makida nene over test positive ne 134 tambah amenta idane ho idane kan positive test ne maka kolom idane. So therefore the probability is about 0.328. All right? Comprende?
I'm sorry, sir, I have a question.
What?
I have a question.
Yes, go ahead. What's your question?
I think I didn't say, but where does the 134 came from?
What? Repeat that, please.
Where did the 134 came from?
Oh, 134 is came in from because this is probability that the subject tests positive, right? So this is the positive test result coming from. That will be from 44 plus 90.
Okay.
This 44 over here plus 90, that is 134. This is the block for positive test result. This is negative test result. And this one is subject using drugs. Subject does not use drugs. Okay. Comprende? Did I answer your question?
Yes, sir. Thank you.
Okay. Let's do one more example. Any more questions? Ito pregunta sila.
None, teacher.
Okay. What about this? Okay, this is kind of cool example. I don't know. Maybe if we can calculate this. Favan, you read this for us, number 9.
Imagining you own a store that sells school supplies. The probability of a person going to your store in a particular day to buy books is 30%. However, during the month where students are going back to school after a long break, the probability is 70%. What is the probability that on return to school month you sells your books?
Can you guys understand this problem? Like, can you have any imagination of how this situation may occur in real life? So basically, for example, ano sa so ibi makaloke loza na ingi da lo salam. Asa lorong babain date, lorong biasa date, probabilidade ida be ibi makaloke loza livro ya fan livro sira. Lorong babain date, probabilidade ida nebe ema se mai oninia loza, ide poi sosa onia buku nene nia 30% probability that this person will come and buy a book. Mas B, setelatia feriado, por exemplo, feriado Natal, ini kan feriado Narok ida. Mas setelate feriado Natal, liutes feriado Natal, feriado Narok ida, tama fala escola e fula março ida. Probabilidade, ne kan ema hotu tama fala be escola na, nebe ema basosa be, sada? Supply ba be, sa escola ne kan barak makar basosa, lo salai? Ang probabilidade de hematososare sati betul 10%. What is the probability what is the probability that on return to school month you sell your books? Hold on. I think this problem is a bit confusing. Let me just change to another. Huh? This problem is a bit confusing, I think.
Hmm?
Okay.
Ito ba?
Hold on. Give me a second. Give me agora la hari buti di on screen to. Dari the honey wallpaper to.
Yes.
Yes.
Yeah, teacher.
Give me a second, yeah. Let me just find you a good example that I can, because this is I don't think is a very good example though. I don't want to like make your heads too hurt. Like how you fatuk mo rasli. Ang yung analysis of karakter lalo.
Ha?
Okay, let me look for some good examples. Give me a second, okay? Okay, I think I find. Okay. This is a good example. Helay tong eh.
Come segretario. Ah. Be, sini dong, Be. Atau presenter, presenter. Ah, sini, sini. Foto lagi tidak? Ah, kamu duduk ya? Siap. Siap. Siap, Pak Presenter. Oh, ada presenter. Masih di buku.
Paula, taca microphone, Paula.
Oh, let's go. Gimana ya? Turun pada HCP. Ya Allah. Putih salawatin untuk saya lebaran.
All right. Are you guys still here?
Yes, teacher.
All right. So
Yes.
let's do this example. All right. So a teacher observes the performance of students in a math exam over several semesters. Based on the data, the teacher notes the following events. So event A. Event A, passing the exam. And event B is studying at least 5 hours before the exam. Okay, studying at least 5 hours before before the exam. At least 5 hours before exam. Okay. Now, the teachers find out that, for example, teacher has a total of 100 students. And nihatene katak, for the sake of this example, just imagine this teacher knows that 60 of the students have studied for at least 5 hours. And of those 60 students, 48 of them passes the exam. Okay, but 40 students did not study for at least 5 hours. And from that 40 students, only 10 of them passes. Okay, ini ya scenario, ini ya 60 estudiante, 60 students study for at least 5 hours. And who si sila 60 nene? 48 makapasa exame, pass. Agora, who si fali 40 students nebe resto ne? Sila not study for 5 hours. For 5 hours, selesai. No, khusus sira be 40 nene, sira naing naing sanulu det mak pass, only 10 pass. Okay, so technically from 100 students, 58 of them only 58 of them passes. Right? So what is the probability? We want to determine the probability that the student passes the exam, given that they study for at least 5 hours. So probability that the student passes the exam, given that that has to study for 5 hours. So if we apply the conditional probability formula, what is the formula again? So probability of A and B over probability of B. Now, what is the probability of A and B? Probability that the student is passing the exam and studying at least for 5 hours before exam. Let's say that. What is that? Saya matene. Hari usi informasi na ba kaya na ba barbar klos ne. Saya matene.
Sure, what was the question?
Okay, I want to calculate it. What is P of A and B? What is the probability of that? Probability that the student is passing the exam and at least studying 5 hours before the exam. What is that? I have a formula. Can you guys see the formula?
Yes, teacher.
Okay, what is the probability in the numerator?
10.
What?
44, 44, I'm sorry, 48.
48?
48, and for the B,
48 of what? 48 over what?
48.
Over 100.
Yeah, 100. Yeah.
Right, tama. So sira 48 na maka passing the exam and they study for 5 hours before the exam. Okay, so that's probability A and B. What about just probability of B? Probability
10.
that studying at least for 5 hours before the exam.
10.
No.
800.
B of B only. B. What is B?
800.
60.
What?
40.
It's 60.
60.
Comprende?
60.
To tama sa naman 60?
Yes,
Because there are
60 of 100. Tama 60 na may study for 5 hours. Maybe husi sila 60 na 48 net na pass. So from that, comprende ka lang?
Yes, teacher.
So you
Yes,
get about,
teacher.
so the probability is about 0.8% probability or approximately 80%. Nebe interpret diyan katak there is an 80% probability that somebody will pass an exam if that person will be studying at least 5 hours before the exam. Is this a good probability to do that? So is that a good idea to study before an exam? To study at least 5 hours before an exam? Yes, it's a good idea because you have a very high chance of passing given that everybody has the same probabilistic opportunities, yeah? Probabilistic meaning given that emabalo nila ihabe itasumi katak emabalo ni speed of learning hanesandi. There's a lot of assumption making here, but just this is an example anyway. Okay, comprende to sa inyo conditional probability?
Yes, teacher.
Preguntas Roma?
None, teacher.
All right, so if you don't have any question, our class for today is just up to now. And your homework number 3 is deadline when? I think it's tomorrow or something.
I think 18. I think that's what it
Yeah, I
said.
don't know, maybe, yeah. So we are finished with probability topic. Next meeting, we are going to talk about discrete probability distribution. Okay, so now we are on chapter 4. I'm targeting for us to complete a chapter like this semester. We at least completed 12 chapters. That would be great. That will be so we until ANOVA and analysis of variance analysis, and then everything. That will be awesome. All right. So let's take an absences. Today is 17. Okay, Ademia Leite. Alessandra Silva.
Present, teacher.
Ana Sofia dos Santos.
Present, sir.
Ana Angelica Fernandez. Antonia Kaunan.
Present, teacher.
Antonio de Jesus Marsal.
Present, sir.
Armandino Name. Armandino Gomez.
Present, teacher.
Cancio Lopez.
Present, teacher.
Celso Cardoso.
Present, teacher.
Cidalia Viana. Cipriano Bobo.
Present, teacher.
Ediana Saldaña.
Present, teacher.
Elisa dos Reis Moisés. Eufrasia Pereira.
Present, sir.
Evangelita Suarez.
Present, sir.
Cavani Guterres.
Present, teacher.
Giovanni Muniz.
Present, teacher.
Ildefano Pinto.
Present, teacher.
Jennifer Pinto.
Present, sir.
Jesuina Amaral de Aroso.
Present, teacher.
José da Costa.
Present, sir.
Joshua da Costa.
Present, teacher.
Leonito Bello.
Present, teacher.
Ivania Barbosa. Malequias da Silva.
Present, teacher.
Mario Falo. Mario Marquez.
Present, sir.
Natalia Fernandez.
Present, teacher.
Neusa Mendes. Noime da Silva.
Present, teacher.
Tiana Ribeiro. Noviela Mafalda.
Present, teacher.
Paula Ramos.
Present, teacher.
Paulo Sarmento.
Present, teacher.
Remilde Aroso.
Present, teacher.
Serafina Ximenes.
Present, teacher.
Thank you, everybody. I'll see you next week. Bye-bye.
Teacher, wait.
Yes.
Teacher.
Silva.
Can teacher upload the video from yesterday class?
Yeah, I will upload it. Just look at the. I will upload it probably in a while later or something. Okay.
Oh, okay. Thank you.
Okay. Bye-bye.
Teacher, si Dalo hing teacher.
Okay. Send everybody who's not there. Send by your group chat it.